that this is the first event for the Pan Asian Affinity Network, and want to thank you for all the other affinity networks who has participated in co-marketing and spreading the word on this event. What I want to share now is the kind of the format for today's session before we go to the introduction to the four distinguished panelists. We're going to start out with an introduction, followed by a few questions, probing a lot on data science and artificial intelligence. And then we're going to take questions in the chat. So feel free to send any questions in the chat there, and we'll address them. And then at about 7:45 Eastern time, so about 45 minutes to do it, we're going to have a breakout for each of you to network with each of the individual panelists. So we'll have 4 breakout groups, and then we're going to hold the main room here open for those who are interested in learning more about the Pan Asian Affinity Network. I can see a number of folks from the Pan Asian Steering Committee who's here, so they could join in terms of answering any questions from people that are interested in learning more. So with that, I will introduce the panelists by asking each of them to state their UChicago degree and class, their current job and location, as well as the fondest memory they have at the University of Chicago. So let's start with Joyce Shen.
Great. Thanks, Norman. Really happy to be here. And I suppose I'll go first. So I went to both undergraduate at University of Chicago and also business school. So I'm Maroons all the way. And I was class of 2007, but I graduated in 3 years. And then I went back to business school a couple of years after. So I studied statistics and economics as an undergrad, and then went back to Chicago full-time for my business MBA degree in quantitative finance, entrepreneurship, and others. I think, so my career kind of all tied together now. It seems that, when I was studying statistics as an undergrad in Chicago, all of you know how rigorous that is, especially from a fairly theoretical school, and data science wasn't even coined. But the idea of understanding data, the foundational elements of statistics, how that underpin now, data science, studying linear algebra, I remember, all of that contribute to the more applied work that I do now. And today I invest as early stage venture investor in machine learning AI companies, predominantly on the B2B side. And my other passion is teaching. So for the last 7 years, I had the opportunity to teach as an adjunct at UC Berkeley's Masters of Data Science program, teaching their data science course, effectively helping data scientists to really understand how to build impactful data-driven products and bring those to the industries. I suppose I will close out by saying I have lots of fond memories of UChicago. I lived at Hitchcock, so on the quad. And so, for all 3 years, I had so many really amazing memories, just being on campus, living in that fairly historic dorm, and, enjoyed everything that the school had offered and met many amazing people from the school. So I'm really happy to be here today.
Terrific. Thank you, Joyce. We'll just go clockwise with Kevin Ko.
Okay. Hi, everyone. Yeah, thanks for coming tonight. And thank you, Norman, for organizing and for the opportunity to be here. So I am class of 2012. I got my bachelor's in math at UChicago. And yeah, so I found out earlier this year that I'm no longer considered a young alumni. So still processing what that means. And incidentally, I learned this when they were asking me to donate. They were like, oh, by the way, you're not going to be young anymore next year, so you should give us some money while you're still considered young. But yeah, so let's see. So how did I get into data science? It really did start during my time at UChicago. I took a lot of generalist classes. I dabbled a lot. I started out, pre-med and did all the pre-med track and started out as a chemistry major. And after shadowing, I discovered I I wouldn't want to be a doctor. So I gravitated towards, you know, after trying physics, I thought I might like physics or math. And the idea there was like, what is the field that like I wouldn't have gone into unless I went to UChicago. And that's sort of how I ended up, you know, more on the applied side with, you know, physics. And I ultimately majored in math. And when I graduated, I was like, what am I going to do with this? It's too theoretical. And that's how I ended up looking for an engineering field, and I ended up with operations research, and I did a master's in operations research. And around that time, that's when data science, you know, as a buzzword, it became really popular when I was in my master's program in 2014. And just this idea that if you had the right amount of data, you could predict just about anything. You know, Kaggle was getting really popular around that time. And so, yeah, I was really excited by and really wanted the title data scientist. And, you know, so in some ways, my career has been driven a lot by, you know, the marketing buzz around the term. And I think at this point, we've gone through like one cycle. And, you know, there's a little bit less enthusiasm specifically for the term data science as we're talking right now. And that's a theme I'll want to return to, especially when we talk about trends later in this talk. Okay, and all right, so I think the second part of the question was, what is my fondest memory of UChicago? Yeah, I would say like early on, just like visiting the campus in my first, you know, during O Week, just being in awe of, you know, the architecture and just wondering what would happen while I was there. That's really my fondest memory. I ended up staying in Pierce all 4 years. Joyce mentioned her dorm, and you know, sadly, Pierce is no longer with us. They demolished it, I think, the year after I graduated. So I have some jealousy when I return back to campus and see the new dorm that's been constructed there. But yeah, had a great time there, and really excited to be here tonight.
Thank you, Kevin. Let's move to Darius LeCobb.
Thanks, Norman, and hi, everyone. Thanks for joining. I'm thrilled to be here. I'm Darius. I am Director of Product Management in NVIDIA's self-driving cars group. I'm based in the Bay Area. Graduate of Chicago Booth. I actually applied to and got admitted to Chicago GSB and started in Chicago GSB. But when I graduated, they said, no, it's Booth. So graduated from Booth in 2010. And actually it was at that time that I caught the data science bug. At the time, I was working for a small mom and pop shop company in Redmond, Washington called Microsoft. And they had decided to build a new search engine called Bing. And they wanted to make money with Bing. So they were looking for a product manager for what is called revenue optimization on the ads. And I just had graduated with my MBA, newly minted MBA, and I applied for it. And somehow I passed the interview and I got the job. And that was the time that I basically learned about data science. At the time, we weren't calling it data science, it was just scientists. You know, numbers theory and running a business by numbers, experimentation, A/B testing. For a while, I had a budget of around 10% of Bing's traffic to experiment on, which is a kind of awesome kind of privilege to have. Fondest memory of UChicago definitely goes to a class that I took at Booth called International Entrepreneurship Lab in China, aka the China Lab, in which we actually designed businesses in Chicago to be launched in China. And then we got on a plane, flew over to China to actually test the business plan on the ground. And fondest memory, love that experience. The project that we were working on was actually in implantable medical devices trials. And of course, I don't know anything about devices, medicine, or medical trial, but I was good with spreadsheets and numbers. So they said, well, Darius, you're our CFO. And I thought it was the easiest assignment I could ever get. And I was extremely wrong on that, because anywhere we went to, folks wanted to talk about whether this is going to be a direct foreign investments or a JV, and how are we going to finance all of these. So I ended up doing majority of the talking and presentation there, but it was extremely fun.
Thank you, Darius. Last but not least, Sadak Patel.
Hi, pleasure to meet all of you. It's such an honor to be here. Thank you so much to be part of this esteemed panel. So my data science journey started many moons ago. I studied biochemistry and math at the University of Illinois, did Teach for America, and then worked as a product manager at Accenture for a while. And it was really through those first two post-undergrad experiences that I realized I wanted to find a way to apply data and insights into improving the life outcomes of people, especially in low-income areas. And so that propelled me to do my PhD at UChicago. I did it in SSA, now known as Crown School of Social Policy, and also in biostatistics as well, where I examined how environmental exposures impacted the health trajectories of low-income African-American youth on the South Side and the West Side of Chicago. You know, that experience took me to Microsoft for a summer, where I joined their AI for Social Good program as a research fellow. When I graduated, I was at Harvard for a few years as a postdoc, studying health equity and understanding how technology, particularly telemedicine, mHealth, can improve access to care for rural and low-income urban populations. And currently, I'm leading data science and data product at a health tech company called Waymark Care. We're basically partnered with MCOs like Aetna, and we provide care management to about 50,000 Medicaid patients starting January 3rd. And we use AI and ML tools in order to target patients and provide them with the appropriate intervention.
And the fondest memory in Hyde Park or
Goodness,
Chicago?
So many to remember, but all those late nights at the Reg. I mean, I miss that first floor so much. A lot of good memories, and made a lot of great friends that I keep in touch with today.
Wonderful. I think we can all relate to that. Well, why don't we move on to ask about the trends. Speaking of trends, maybe I'll go back to Joyce. I mean, Joyce, you have a very interesting background, right? You work at IBM, Thomson Reuters, a lot, tech company. And then now, most recently, you're actually an investor looking at a lot of startups, probably in the data science AI space, as well as teaching. What are some of the key trends that you're seeing that would be of interest for us? Because I think data science is a buzz term, like Kevin was saying, a lot of conception of what that is. What would you say are some of the key trends you see that particularly pique your interest?
Yeah, thanks, Norman. I'll just point out one, because we have amazing experts on this panel from different industries. So, I mean, just in the last 5 years, if you look at these very large language models, many of you may have seen ChatGPT, or you have seen people posting kind of cartoonish, graphic designy, artsy like images of themselves on LinkedIn. These generative AI models will have huge impact, I think, to the way that we think about what are the new products that could be made out of these large models. What are the automations that could further be implemented in different enterprise workflows? And what are some of the questions relating to these models that can generate things that are now very good? Question and answer systems, search engines, art, and many others. And that's the most top of mind example of how rapid advancements have been made just in the last few years because of computation power, because of data, and this idea of crowdsourcing data and training information to make these models much better. So I just want to point that out as something that's top of mind, and also most recent, I think one of the most recent development. In general, I think the application machine learning AI are still in the very early stages of kind of adoption. From my perspective, it's in early innings of this, and we're solving interesting problems, but there are a lot more problems that could be solved across different industries. And so a lot of opportunities ahead, but also at the same time raising questions that we'll have to wrestle with.
Wonderful. Kevin, you started in 2012, and when you and I caught up earlier, you mentioned that data science wasn't even a term yet, but you always been very analytical and mathematical, and got into engineering. Tell us a little bit what you see as some of the trends now that you're actually working very much knee deep in the data science industry.
Yeah, so I didn't actually cover where I am right now. So I am a data scientist with Capgemini, and my current client is Meta. So somewhat close to what Joyce just discussed. And yeah, like what I was saying about the hype around the field of data science, and a lot of companies, there was like excitement, and companies felt like they needed to hire data scientists or they might get left behind. This was probably, the first 4 years after I graduated. And where we are now is that a lot of the hype has died down. A lot of companies find they simply don't have the infrastructure and the operational know-how to utilize data scientists in a way that actually adds value to their companies and their bottom line. And given that the economy has started to slow, that some of the more speculative research for data sciences is being cut, and what is really focused on right now is like the bread and butter with the traditional stuff, right? Statistics. A lot of the data science postings you see, like analytics data science, which is more or less the analyst position before data science became a real buzzword 10 years ago. So yeah, that's the trend that we're seeing. We're seeing like a return back to basics for a lot of these positions. I mean, there still are, positions where you will do research on like the really exciting things like ChatGPT. But yeah, there aren't very many of those, and it's hard to get them unless you have a PhD. So, career-wise, that's sort of the trend that's going on. Another thing I would add is that like causal inference, a lot of the tools that is in UChicago's wheelhouse, that's also trending right now. One thing that I've noticed. And so there's like a shift, for example, between attribution modeling, which was used in ads to, assign credit to like, what did these ads cause, to using econometrics and causal inference to determine the impact of ads. So yeah, that's a really exciting trend that I think is, it works out really well for UChicago.
Wow, that's wonderful. Hey, Darius, tell us a little bit more, because you strike me when your background was around, you were at JP Morgan, and when they were trying to start AI, you were at Bing. It seems like some of the big companies trying to get into it, you were at the forefront, and now you're in NVIDIA. What are some of the trends that you're seeing in the data science field?
Actually, there are two trends that I'm kind of very, very excited about. One, kind of building on what just mentioned around generative AI, and mostly around foundational models like GPT-3, ChatGPT. The ones that I'm more excited about are models like DALL-E or Stable Diffusion, that they get some text, some description from someone, and then they generate an image that describes it. If you actually take that to its kind of like logical kind of conclusion, then it kind of sort of can replace some of the artwork that one needs to do for synthetic data generation, building the world in a metaverse type of an environment and things like that. So we are super excited about that side of the work. The other one that I think, at least I am equally excited about, is what I call it the idea of creating robo-data scientists. So if you think about some small businesses, let's say a small business that needs to go on Shopify and then grow, in today's world, they can't grow without having some level of data science and principled data analysis on the staff. And most of these small businesses can't afford a full-time, fully qualified data scientist on their staff. So we are seeing some startups popping up that they said, okay, if you had a data scientist, what questions would you ask this data scientist? So let's create a list of those questions. And now let's train an AI that can actually answer those questions on your behalf. So we've seen a few very interesting startups kind of popping up here and there. And I think that's a very, very interesting trend that we see in the startup community and where some of the VC money is going right now.
Wonderful. Sadak, feel free to add to it, but one of the things that caught my eye about your background and is about how you're applying data science in the area of healthcare and Medicaid, and solving a real important problem that we have. And not only that, it seems like when I actually interact with people who are data science, getting data, access data is actually a big aspect, but you seem to have actually a lot of really good data. Maybe you can talk in addition, what trends you may see about kind of what you're doing in that field.
Yeah, absolutely. So I want to kind of reiterate what Kevin's comment was, taking a step back to more the traditional, I'd say, bread and butter, causal inference, natural experimentation. And so I think a lot of the work we're doing at Waymark is, I would say, more traditional health economics in conjunction with ML and AI. And so one of the key questions that we're trying to answer is, we have responsibility of 50,000 Medicaid patients. You know, the statistic that 10% of Medicaid patients account for 90% of the cost. And so if we could define models that are able to target that 10% in a meaningful way and send care delivery to them, whether it's in the form of social workers, community health workers, in order to triage that care with primary care physicians, we might see a decrease in that cost because they'll stop using EDs and inpatient care, which is quite expensive. And so one of the things we're exploring through partnerships with the MCOs, where they provide us with their health claims of those patients for up to 2 years prior to the intervention, is how can we in a meaningful way integrate health economics with AI and ML to better target that 10%? And so some of that is using time series analysis in conjunction with quasi-experimental, in conjunction with neural networks. Now, as Joyce mentioned, we have more computing powers. I think on the flip side is, it's one thing to target patients, but there's only a finite amount of resources. We can't hire 200 care workers for a patient population. And so we have to understand which patients can we send a text to remind them to take their medications so they would avoid an ED visit for diabetes, which patients will require a phone call, a video chat. And as you can see, you know, to a door knock becomes more and more expensive as you go up each level of intervention, and requires more time in a day. And so how can we use reinforcement learning tools, recommender systems, you know, multi-arm bandits, in order to understand, given a subset of patient characteristics, which intervention will they respond to in a meaningful way, so that we could tailor more what we would call intense interventions towards patients that will not respond to a text message or a phone call.
Great, wonderful. I also posted on chat that if you guys have any questions, feel free to pose it. I'm going to go with the next question in terms of real world problem. I recently talked to a data science that I've been working with. I work at the University of Rochester. We look at data in terms of clinical data, and he works with a lot of different clients, and he shared that 90% of what we work on data science never become a new product or services, et cetera. And I'm looking at people nodding, and I would like to ask the panelists about what is a real world data science problem that either you or you come across, or you worked on, and what did you learn from it? Maybe why don't we start with Kevin, because he's nodding. Seems like he has a few answers on his head already. Kevin.
All right. So yeah, I think so. One problem that comes to mind, it was my first project at Capgemini, which was also, as it were, based on a buzzword. It's AI ops, right? So we were hired by a telecom company to come in and build this prototype of an AI ops product. And what AI ops is like using artificial intelligence to smooth out your operations. And their issue is they had this enormous backend system that handled requests for finding things like if a division needed to look up someone's payment information, or then the system handled that. And they had a lot of different requests going on, and the system also failed a lot. And they needed something that would give them some lead time to know when a failure might occur. And that's what we were brought in to build. And on this project, I saw a lot about, like, in the sales cycle, what we did to convince them to do this project, and how we came in, not really knowing how their systems worked. I mean, we had some people on the inside, but just like, it was a lot of what we were doing was like a sales job. And it was interesting to see the work that it took to take that little grain of an idea and build something exciting enough so that they might buy a second phase of the project, right? And so I did this project like a year and a half ago, and I'm just now hearing of the outcome of the project, which is that they signed a contract, not for the second phase of this project, but for a analytics center of excellence. So we were able to prove that we had some expertise in this area, and help expand the contract for this client. Now, so what was interesting specifically about what I built? So we had a lot of data. We picked it from two systems where it was clear, what the format was. Like when you're in the weeds working with data, a lot of the issues will come with data cleaning, and we had to be very precise in the systems that we picked and the data that it would output. And then once we chose the subsystems where we were going to pull the data, there was a lot of exploratory work to see what methods would or wouldn't work, right? So at first we tried to make it like a forecasting problem. Can we forecast a really large increase in requests to the system, for example? And that turned out to be really difficult to do, and we didn't really have the data for it. One issue is that, like, we were trying to figure out when failures would occur, but we didn't have a robust data set we didn't have a robust labeled data set that said, like, these are all the failures that have occurred recently, and you can train on this data set, because they didn't really store the data, and it was all erased after 3 months. And as it got closer to the 3-month threshold, they deleted the granularity of the data. So yeah, there was no data to work with. And yeah, so we just iterated, and eventually it became a unsupervised learning problem. And we were able to build like a graphical display that helps surface when failures might occur. And yeah, so that's what we delivered. And it was on a tight timeline, and a very interesting project that really explored, like, what does it take to make a feasible data system that people that don't know as much about data science can use.
Wonderful. Darius, do you have anything to, given your broad experience about the problems that you solved that either turned the product or did not turn the product, was very interesting, and you learned a lot?
Actually, one that I will bring up is actually around AI ops that Kevin just mentioned. So a little while ago, a few years ago, I was working on the building a database as a service for Azure. I was part of the group that wanted to make sure that on the cloud side, the way that databases are deployed and are being used and things like that is actually managed from an operations standpoint correctly. One of the problems that we had was that we wanted to patch either the OS, the operating system, or the database itself. And anytime that you actually want to upgrade and update the system that is running someone's database, you need to make sure that they are not working with that data. The thing about data is that if it is actually drops, it's like hair, it doesn't grow back, and you always kind of lose it. So the problem that we had was, okay, how can we predict which instances, which customer workloads are probably going to not be touched over the next X number of minutes or X number of hours, so that then we can start updating those systems. And by the way, of the ones that are probably going to get touched, how can we bring up redundancy in our system? How can we bring up secondaries and tertiaries so that as we are upgrading part of the system, the database is still kind of up and running? And in order to solve that problem, we had to just reframe the problem, frame the problem in a particular way, go instrument for data points, capture data points, create a data set, train a model around it, experiment on it. As you can imagine, experimenting on real enterprises' data and databases is a challenging kind of a task. So learned quite a bit about what is a field that now we actually call it AI ops in general. So it was a very, very interesting journey that we went through.
Thank you. Hey, I want to turn to Joyce. Joyce, you actually interact with a lot of startups, other companies, and so forth. Maybe you can share a little bit. I mean, we have an audience here probably was interested in, what's the latest, the greatest, but what actually really work, right? Because there's a lot of probably startups that doesn't work. So what are some of the things you see that are interesting problems they're solving and is actually, getting traction, if you will?
Yeah, I can touch on some of the kind of the problem space, if you will, and then if we have time, we can talk more about the specific problems in breakouts. Kevin and Darius actually touched on one, which is about AI ops or machine learning ops. How do you make things work better, more efficiently, giving tools to data scientists, data engineers, because they do spend a lot of time on data wrangling. I've supervised and advised many projects, and also in companies where they have great ideas, but they don't really have the data. Or if they have the data, they don't know how to actually find the features or the labels of that data. And actually it's quite difficult. And it becomes a differentiator in a lot of these businesses when they have proprietary data that are labeled by domain experts or have that knowledge, domain knowledge, to be able to help them find insights in those data that otherwise would not be necessarily uncovered. And so that's actually interesting problem in itself in the machine learning AI space. But more on the apply side, everybody's using lots of machine learning AI products on their phones and computers, and when you shop, the recommendation systems. I won't talk about a lot of those, but there are a lot of people, at least on the academic side of my work, looking to apply machine learning and AI to for good. And so thinking about areas where machine learning is not prevalent yet, looking at, for example, how do you actually use image recognition or computer vision to detect different kinds of parasitic worms or parasites in certain kinds of diseases in emerging markets where they simply don't have the resources. But if you have a mobile phone, and you can take a picture, of the waste, and you can then have a, on the device way of identifying what's the probability of that being a parasitic disease or not. That's an actual project that's being funded by NGOs to take that into the field. And there are many other projects where I think today, Sadiq will have more perspective, but looking at the social side of things. So looking at food deserts, looking at electoral college, looking at social inequality, income inequality, looking at access to care, looking at access to education. I think typically Chicago used to say these are, econometrics or sociology and problems. It's actually very interdisciplinary, because now we have more data. You can use what's used to be called regressions, right? It's supervised machine learning, the fancy way of saying that, to apply those to problems that always existed, but bring both domain experts who are not necessarily data scientists and the data scientists together to uncover potentially new solutions to problems that people have wrestled with for a very long time.
Terrific, Joyce. I can see there's some questions in the chat. I know we also have about 9 minutes before the breakout. So I want to jump to the questions, and I suggest to people who want to we can actually go in, and it seems like Darius ready to answer a question on chat. So to go to breakout with their panels to ask about causal inference and trends and so forth. So the last question I would pose is, what would be the one career advice now that you've kind of in the field of data science you would give to someone either already in data science or AI today, or looking to explore to make a change because there's so much excitement or if you want to call hype, but at least growth there? What is the career advice you would give? I would say I would go with Sadak because he actually has an interesting background, because I think your PhD or master's in social work, right? So it's not like you need to be the hardcore, engineering, data science. So love to get your perspective, and we'll go around the horn.
Yeah, I would say, what's the expression? The forest from the trees. I would say get a deep understanding of the use cases and try to understand how the technology or tool can address that business need or that use case or the problem you're trying to solve. I think one of the challenges I see on my team in particular is we have such a great group of data scientists, incredible Python programmers, SQL, have a really strong ML toolkit. I think one thing that separates the exceptional ones from the great ones is their ability to understand under what situations to apply one tool or the other, and to understand the specific healthcare delivery that they're trying to optimize for, and really leading with those use cases in terms of what to optimize. That's one piece of advice. I give myself time and time again to take a step back and try to become as much of a domain expert as you can with the experts.
Great, thank you. Let's move to Kevin.
Yeah. So yeah, it's difficult to decide what you want to specialize in data science, right? It's like I've said a few times, there, trends, the buzzwords, they disappear very quickly sometimes. So, and I'm thinking about what I want to specialize myself in right now, or, whether I want to be, managerial or generalist. So I don't have everything figured out by any means, but I would say, yeah, just let yourself explore your interests, and it's okay if trends subside, right? It's the nature of this field is such that, like, if you become the best at something, in 4 years you can make a big impact, even if the trend switches. So yeah, my advice would just be follow your interests and give yourself the freedom. At the same time, it is still very important to know the fundamentals, the basics. Just know your statistics well, and that's always something that, yeah, it'll always be used.
Wonderful. Darius?
I would say the fundamentals are, of course, important. They're critical. Just basic stats will go a long way. But in order to be successful in data science, you also need two other things. You need to know the domain that you are doing data science on, and pick a domain that you are excited about. If it is about investment banking, understand that. If it is about retail banking, understand that. If it is about social science, understand that. Without having a good grasp on the domain, you will have a hard time being a very, very impactful data scientist. And to that extent, number two, pick up some storytelling muscles as well. A good data scientist will tell the story of the data in the language that the audience is trying to understand it, and they can connect to it. So being able to talk to statisticians using statistics nomenclature, and to executives using business nomenclature, and to anyone in between using whichever nomenclature that makes sense to them, will go a long way to increase your impact as a data scientist.
Terrific. How about you, Joyce? You do a lot of students as well. One thing I want to ask is also, I deal with them. What about like these programming languages? And is that also key to understanding? Because you heard about statistics, about domain. and there's all these Python and R and different aspect. I just want to get your thoughts in general about career advice, and also that I didn't hear much about that, but I'm kind of curious what your thoughts about how important those are.
Yeah, I mean, we have others in the room here who can tell everybody what technical program language to use. I mean, I think Python is something that's bread and butter for everybody. I was taught R at UC, and I remember how it was coded with, it was many years ago. And so in many ways, it's much easier to learn programming now. And there's so much resource out there. And I agree with all the advice being shared. And my only advice is, I think sometimes people think that you have to be a technologist. You need to have a technical background to get into technology and to get into data science, when in fact, there are many different paths to become a valuable contributor to the field, whether it's on the technical side, whether it's on the product side, or in many organizations now, model governance, compliance, ethics, data visualization, I mean, you name it, right? This is a horizontal area where it really takes different kinds of stakeholders to make something work and work for everybody in the room. And so I just really encourage those who are in data science to heed the advice from the other three panelists and who just share their view. I totally agree, but also continue to learn. This is, I think in UChicago teach all of us to really be those who are in pursuit of knowledge. And in data science and AI, this moves so fast. Even for people in the field every day, I think they don't know everything. I don't know everything. And being able to adapt and to have that aptitude to just pick up something, learn, read about it, ask questions, see what other people are looking at, what they're building, having those conversations will go a long way.
Great.